All right, welcome to part 2 of the Cramer's rule for this ridiculously long problem. All right, so in part 1, we had this system of equations here, and I forgot that I had meant to create this problem with A, B, and C instead. So it's not a big deal, but I went through and I changed all my X's to A's and my B's to Y's and my Z's to... I may have said those all. I may have said all those backwards. Anyway, I changed my Z's to C's and Y's to B's. Anyway, so in that last video, we found the regular determinant, so the determinant of the overall one. We did that by hand, and we went ahead and did d sub x as well, or d sub a in this case. So we got those two. In this video, we're going to find d sub b. All right, and d sub c, but we're going to use our calculators for it. So make sure you have the old TI-84. All right, so to find d sub b, the determinant in b, I'm going to replace the b column, or the y column, whatever you want to call it, with the 4, 32, and 7. Okay, so 4, 32, and 7 right there. And for d sub c, I'm going to replace that third column where it was all ones. I'm going to replace that with 4, 32, and 7 likewise. 4, 32, and 7, like that. Okay? Now, to find the determinant of this, instead of doing that expansion by minors method where it took forever. All right, instead of doing that, I'm going to go ahead and open up our TI-84 here. And where you're going to go is the matrix menu. It's been a while, but it's right there. So you're going to click on second and then matrix. All right, and ignore the second one here for a second, but on matrix A, we're going to go over to edit. So arrow over. All right, and then this way we can type in that matrix. It is a 3 by 3, so we'll do 3, enter, 3, enter. And we're going to type those numbers in for this d sub b here. All right, so it's a 1, then a 4, then a 1, then a 9, then a 32, a 1, a 4, 7, and a 1. Okay, so make sure you hit enter on that last one so that it says 1 there. And we're going to quit. Then we're going to go back to matrix. All right, but this time we're going to go to math. All right, this is going to do some matrix math here. So determinant, that's the one we're going to use. And we're going to tell it what to find the determinant of. So second, matrix. And we want it to find the determinant of this first one. So under names, you're going to select that first option, A. All right, whatever the matrix is that you're finding the determinant of. All right, enter, and we got negative 60. So let me go ahead and record that. So my d sub b was negative 60. So I'm going to write that down. And let's go ahead and find the determinant in C as well. Okay. So if I go back into matrix here, what you could do is you could go over to edit, or you could, I guess you could go over to edit and then go down and create a new matrix. But I've already got it entered in to matrix B here. I've went ahead and replaced, that third column with 4, 32, and 7. So all I got to do is quit and go back to my math menu, determinant, and I want to find the determinant of matrix B. Okay, it gives me 100. Nice round numbers here, 100. And that was my determinant in C. All right, now that I have these 4 pieces here, I can go ahead and write my answers for X, Y, and Z, or as I changed it to A, B, and C. All right, The way you do that, remember, is to do d sub a divided by d, and whatever that divides out to is going to be your answer for a. So in this case, that's 40 divided by 20, which is 2. Let me change this to another color here. And then for d sub b, so d sub b divided by d, and that's going to answer for y, or b in this case. That's negative 60 divided by 20, which is negative 3. And then that last one, come on back, there we go, is d sub c divided by d, which is 100 divided by 20. All right, let's see. And that comes out to be positive 5. So these three numbers, 2, negative 3, and 5, those are our solutions for this original equation. All right, but in A, B, and C. There we go. So 2, negative 3, and 5. Now, I didn't tell you this up front, all right, but what this was it was a problem that I had made up to describe, all right, golly, I don't know how to say it. Anyway, I have these 3 points over here, 1, 4, negative 3, 2, negative 3, 32. And what I was searching for was a quadratic or a parabola that passes through all 3 of those points. Now, you might recognize these numbers. All right. The other numbers, don't worry about how I got that. I mean, if you want me to show you, I can. But anyway, that original matrix setup, that original equation back here, that's what I'm going to end up giving you in your homework, and you're just going to be applying the Cramer's rule and solving it out. All right. But I wanted to show you real quick kind of what we were doing. Was we were looking for a general quadratic, ax squared plus bx plus c, all right, so that it passes through each of these 3 points. All right, so if I substitute in my values that I just found, all right, y equals 2x squared minus 3x plus 5. This quadratic passes through all 3 of these points. And then to show that, which this is something you're going to have to do on your homework, is you're going to plug in 1 for x, and hopefully you get back 4 for y. So you would do 2, you would plug in 1 for x, all right, and then work this out, and you're going to see that it does give back a 4 for y. And the same goes for plugging in negative 3. All right, if you were to plug in negative 3 for x, let's see, negative 3 plus 5. And if you were to work this out, you're going to get that 32 back. All right, so on your homework, it's going to be, hopefully it's straightforward. I tried to make it pretty plain, cut and dry for you. But this is one of the applications for solving systems of equations. Is you can use it to answer questions like this. I got 3 points, and I want to know what's the quadratic that passes through all 3 of them. All right, so don't forget, you've got that calculator to help find the determinant of those matrices, and I hope that makes it a lot easier on you. All right, guys.